Hello, welcome back. Mastery P&ID and other schematics. Practical approach for complete beginners. Self-learning. How to examine, interpret, draft P&ID and other schematics diagram. Today we shall be looking at chapter 13. Cause and effect chart or diagram. A cause and effect diagram is used in system dynamic modeling to identify instrument loops and connection with the process unit for accident prevention. It helps in the design of control structure in a process plan or in a process system. Cause and effect diagram deal with the condition of what, when, why, if, how, and what if necessity for a process plant system. It is prepared in conjunction with safety philosophy and system design premise. It provides the logic information for planned and unplanned operation problems. It shows an action that will result when there is change in the operating status or alarms, showcasing all possible variables affecting process output, including the set point, values, and the trip offsetting when there is deviation from the target point. Although cause and effect diagram are originally used for quality control assessment, its technique can be used in process plan design to find out the causes of a problem, identify bottleneck in process plant, identify reason why process system is not working properly, identify units that need revamping and optimization. Typical basic layout of cause and effect diagram. For illustration purpose, we have here a basic layout of cause and effect diagram showing the effect, the causes of the problem, factor of the problems, and the possible causes. For illustration purpose, this layout, we are possibly showing the grammatical layout or how cause and effect can be represented in the form of diagram in a process plan. Here we have the causes and we have the effect. We shall be identify three types of cause and effect diagram, which include 1. Enumeration diagram, cause type, which is used to outline possible causes of major problems. 2. Analysis diagram, which is the dispersion type, used to analyze the causes of irregularity in the system. 3. The analysis diagram, the process type, which is used to study features of the problems. Taking a look at cause enumeration diagram. The cause enumeration diagram involves the creation of the foreseen problem at the right hand side of the page, as shown in figure 13.7.1 to figure 13.7.4. In this cause analysis, create a long arrow to it and make lists or group of arrows on the identified problem. Tag them as the possible causes. Create a rectangular box at the end to show the possible effect as a result of the action of the causes. The dispersion analysis diagram is the formation of the problem, beginning from the end of the right side of the page. Group the problem into their general category, as illustrated in these figures. Create long arrow to it. Make list, branches, or group of arrow of the classified problem and tag them as a possible cause. Add rectangular box at the end to show the possible effect. The process analysis cause and effect diagram are created for process study. The causes are listed in left section while the effects are listed on the top section, as illustrated in the figures 13.7.1 to 13.7.1. They are described in their tag number and their description, alarm trip off, actions, function of the input and the output devices. The emphasis is listing the causes in the sequence in which the operations are actually conducted. Benefit of cause and effect diagram. They allow for full description of inconsistency observable factors. They provide simple plan of occurrence which can be investigated and eliminated, or process override and maintenance override where applicable. They identify occurrence of event when and where adjustment is made. They are well comprehensive. They provide the information of the cause of a problem and the action that will help deter the cause and the effect. Advantages and disadvantages. In the advantages, it helps to identify origin cause of a problem phase by phase. It is applicable in any industry. It is used as a presentation tool for a clearer explanation for people with limited knowledge of the scope of causes and effects. The graphical and diagrammatical interface make communication very easy. Disadvantages. Difficult to illustrate overlapping of causes of the same problem which could lead to other problems. Where causes are known to the problem solver, it may not provide significant solution. A further laboratory evidence may be required to find the source of a cause. If the condition what, when, why, if, how, what if necessity is incorrect or are incorrect or meaningless, the whole process can be thrown away. Since it involves logical reasoning, different approaches may produce different solutions. The solution to the root problems may not always be linear. There could be a complex relationship between factors and their interconnection. Limitation of causes and effect diagram. Some of the main limitations of causes and effect diagram are listed below. The chart is not based on general knowledge or standard. The possibility that not all the causes may be identified and listed on this diagram or on the diagram by the specialist is not sacrosanct. It provides logical reason to deter the core of the problem. It could be that the causes identified as the most important ones may not be the main problem. Where the problem is dynamic, the causes may continue alternate with invalidated data. C&E diagram does not highlight or show interrelationship between root problems and causes outside linearity. Nevertheless, C&E diagram should be used at the initial phase of a project after development of the P&ID to analyze the causes and effects of the problem. It should be developed with the process safety philosophies and the process design premise. C&E analysis to development. Step 1. Identify the problems. Mark out the problem as observed. Identify the source of the problems. Pen down the problem beginning from the left side of the paper. Draw a horizontal straight line to the box. Begin to develop the logic or ideas of the problem's identification. Step 2. Identify the key categories of the factors of the problem. This may be system bottlenecking, equipment, external disturbances, operators, and so on. Include as many finding factors as possible. Include any other logical factor that can affect the process deliverables. Include side line on the diagram and label these lines. Here, these figures for illustration purpose, as explained above, identify the main categories of the factors of the problems. Step 3. Identify the possible cause of the problem. Show the likely causes as short line going to the major line on the diagram. For a complex system with numerous causes, break down the causes into sub-causes. For illustration purpose, this diagram is C&E diagram. Identify the possible cause of problems. Step 4. Analyze the problem's detail level. Begin the investigation of what could further cause additional problem, and then develop the effect action due to the functions of the source of the problems. For illustration purpose, this figure is showing C&E diagram analyzing the process details level as explained above. Let's take a look at practical illustration of C&E chart. In this practical demonstration, in this study, we have 3 P&ID diagrams: 101, 102, and 103. High pressure separator, medium pressure separator, low pressure separator, and atmospheric separator in some of the diagrams, each with high level alarm, low level alarm, and switch sensors, that is digital sensors. When there is anomaly from the target value, the status of the alarm will change. This will cause logical effect and prompt an action of the final control element to either close or open in response to the effect of the causes. The causes and effect chart provide the logical information for the alarm trips. It is prepared in conjunction with the safety philosophy and the process design premise. This causes and effect diagram provide the logical information for planned and unplanned operational failure. It shows an action that will result when there is change in the operation. This causes and effect diagram provide the logical information of the status of alarm, including set point values and the trip up setting when there is anomaly in the target value. In the figure 30.8.1, is shown a typical process plant of C&E diagram layout used for illustration purpose. The figure 30.8.2 shows an outline of the interface of the C&E diagram layout. Then we have the table 30.8.2, which showcases some definition terms on the P&ID. The figure 30.8.3 outlines the steps involved in creating C&E diagram, defining and detecting problems, finding the factors of problem, identify possible causes, finding the root problem, and then creating the effect action. Consider the high pressure test separator on high pressure alarm on the P&ID number 101 as shown in figure 30.8.3, tag number 300 PAHH-0011, pressure alarm high. Assuming the alarm will trip at above 80%, this will create an effect that will make the valve tag number disk to close. This will create an action that will make the valve tag number 300-UV-001 to close on the local function. The valve 300-PV-001 will open. The valve 300-PV-002 will open on automatic function as designated in the chart. The consideration as described above can also be implemented on the other separator and unit or equipment, and on P&ID 102, 103 and others units. However, the technique is to spot the problems and causes associated with the operational unit. Consider the function that will create an action due to the predictive problem and the effect that will be generated. A careful observation of the NP test separator on high pressure alarm on P&ID 102, figure 30.8.3, tag number 300-PAHH-002, show that the alarm will trip when there is deviation or deviance is above 80%. The effect will create an action that will make the valve tag number 300-UV-002 close on local function, 300-UV-004 to close on local function, and valve 300-PV-002 to open on automatic function as designated in the chart. However, this consideration can also be implemented on other separators and unit or equipment, and on P&ID 101, 102 and 103. Each cause and effect can be examined, removed, or by process override and or by maintenance override if it's not important, through the alarm acknowledgement and ports during process operation by the operators. Table 30.8.1 is for illustration purpose, showing the information of the P&ID number 101, 102 and 103. The P&ID numbers, tag number, description, set point and actuator or control element must correspond with that on the causes and effect chart. Here, for example, we have the P&ID number, then the unit, then the tag, then the description here and the set point, and the action for the control valve, what will happen when there is a trip on the alarm. Take a look at this P&ID number 101. with the unit 300-VP-01. The tag number is 300-PAHH-001 trip. The description here is telling us that the test high pressure separator is on high pressure alarm and the set point is 80%. When there is deviation from this point, or when this alarm is going above 80%, when the trip occurs, the valve 300-UV01 will close. The valve 300-PV-001 will open, and the valve 300-PV-002 will also open. This is what we have. This is the control room. When there is no trip, hook condition or normal condition, when there is no trip, the valve 300-UV001 is on close. The valve 300-UV02 is on close. Take for example the P&ID number 101, unit 300-VP-001, tag number 300-PAH-001 trip. The description is telling us that the test high pressure separator is on high pressure alarm, and the set point for the high pressure alarm is 80%. So when the operation is normal, or when on hook condition, the valve here are all closed. 300-UV-01 are all closed. But what happens when there is a trip? Action. 300-UV001 remain closed. 300-PV001 will open. 300-PV002 will also open. Let's take a look at the P&ID label 102, unit 300-VS-001, tag 300-PAH alarm, PAH 300-PAH-002 trip. It's a medium pressure separator, high alarm. What happens when there is deviation, or when the alarm or the level is above 80%? The valve 300-UV002 will close. 300-PV003 will open. However, in designing the cause and effect diagram as explained in the tables above, it can also be represented in the form of a chart. Here we have the causes and effect chart. We have the effect that will come up and the action that will follow. Then we have the possible cause too here. Here we have the operation of the Houston. We have the legend. Then we have some defined functions here, where S here represents our electrical signal or an action as a result of electronic signal. Then C is an action as a result of a pneumatic signal. Then the P here represents a permissive error action. Then we have the overall MO, maintenance override. We have the override as maintenance override or process override. For the reset, A means automatic reset, the L is local reset or local manual. The arrow is refer to the remote operation or remote operation. Here the appendix 2, which gives us a detailed explanation of the causes and effect chart as designed. Abbreviation, like I said before. Then this is our legend. So we always have the task name here. Then we have the effect of the action due to the causes as represented here. This is our legend definition. We have the functions, the override, and the reset terms represented in our legend. Here we have the cause. Here we have the possible causes. In the possible causes, we have the P&ID number, we have the unit, then the description, override, reset, or whichever way. Here we have the logic information of the status of the alarm, set points of value, alarm tree, action due to deviation from target value. Here we have the function from the action, or the function from the action due to the causes. See on our charts, these are the possible causes. We have the P&ID number, we have the unit, the description, whether override, reset, and we have the tag number. Now we now have the effect of the action due to the causes, or what will happen as a result of the causes. So the effect of the causes, the effect that will result: high alarm pressure on the P&ID number 101 as shown in the figure 30.8.3, tag number 300 PAHH001. Assuming the alarm will trip at 80%, this will create an action that will make the valve tag number 300 UV001 to close on local function. The valve 300 PV001 will open. The valve 300 PV002 will open on automatic function as designated in the chart. Consider the P&ID number again. Here the P&ID number 100 unit 300 HPV01. So the description here is telling us it's a test high pressure separator on high alarm pressure alarm, or high pressure alarm. Here the P&ID number 101 unit 300 HPV001. Description here is a test high pressure separator, high pressure alarm. So we are looking at the cause here. So I'm drawing this arrow that any cause can come up. What will happen if there is a trip as a result of the level going above the set point? We have the S. For this one we have the S, meaning there will be an action. There will be electronic action. There will be an electrical action. Here again, the second line we have C. That means that could be a pneumatic action. Okay, so what will now happen? What will now be the effect? This particular line now, I will trace this one. What will be the effect of this here? Tag number 300V001. We are still going. Then this valve will close. So what will happen? The electronic valve here, leave tag 300V001 will close, as you can see from here. The same thing is applicable here. There will be a pneumatic action on 300 on the PV001. What will happen? This valve will open. Here there's going to be another pneumatic action on 300 PV002. What will happen? This valve will open. Let's take a look at another P&ID number, unit 300 MPV001. Is MP separator, high pressure alarm. Override, manually override is possible. Local override is also possible. Automatic override here is also possible. So the alarm trip number is 300 PAHH002 with trip. Here we are going to have the S function, the S function, and the C function. What will happen if there is a trip? What will be the effect? We come here, the valve 300V002 will close. Here the valve 300V004 will also close. The valve 300PV003 will open. This description can also be implemented on other separators and units or equipment as deemed fit. This explanation is also applicable to other P&IDs, unit number, as deemed fit. I leave you here with quick exercises. Thank you.